Welcome to the Developer Server's YouTube channel. On today's episode, we're going to be building a Tic-Tac game in Pygame. As usual, we're going to be following the blog post from the Developer Server's blog. I will leave a link in the description for the blog post and also a link to get the source code. So let's see how we can build Tic-Tac-Toe in Pygame. So it is the game. First, we're going to be building the game with 2 players. And next, we'll be doing the game with 1 player and playing against the computer. So this is 2 players playing the game. See how we play. As you can see, we play normally and we win. This is one of the possibilities. And this is 2 players game. And later on, we're going to be, like I said, implementing AI to play against the human. So let's see how it's built in terms of the code. So here is the code that we're going to need. We have our requirements, of course. First of all, we have Pygame, because of course we're going to be building the game in Pygame. Then we have the Tic-Tac-Toe version of the game. This is the 2 players, 2 humans against each other. And then we have the Tic-Tac-Toe with AI, which is the human against the AI. So let's take a look how we first built the game with the 2 human players. So let's see how we implemented the Tic-Tac-Toe Py file. So we import our Pygame in terms of the imports, and of course also the system, because we're going to need this later on. We start by initializing our Pygame with Pygame init. We define then a couple of variables. We define our screen size in terms of the width and the height, and also the line width, which is when the player that is between the different rows. The win line width, which is when the player wins, and the line that goes across the player, as you saw before. Then we have the variables for the color definitions. We're defining which color is white, black, and red in terms of the RGB values. Then we define our board in terms of how many rows, how many columns, both 3. We define the width of a square so that we can use that later on to draw. The circle radius, which is to draw the circle player, and obviously the width also. The cross width, which is to draw the X player, and also how much is the space itself where we can draw. Then we initialize our screen. First we are setting our display mode to be the width and the height, and this we store in the screen. And then we also set a caption for the game, that is the Tic-Tac-Toe, and we fill in the screen, that comes from setting the mode. We fill the screen with white, which would be our game background. And finally, we initialize the board, which we will store in the board variable. Pretty much we're iterating between the columns and between the rows, and all of that we are filling in with 0. So the board is going to be a simple list of zeros, 1 or 2 when one of the players is filled in, and zeros when it's not filled in, and that is just one flattened list that we store in the board variable. So let's see now the several different functions that are defined to helper functions to help with the game logic. The first function is going to be used to draw the lines. So this will draw the horizontal lines and also the vertical lines, so that fills in the space between the squares. So pretty much we're first drawing the horizontal ones. We're drawing a line, a black line, and the start position is that top left, and the end position is going to be the square size and the line width. The same thing for the vertical lines. We're drawing also a line that starts at the 0 position of the square and then finishes with the square height and also the line width. Next, we're going to be drawing our figures. So when the player has played, so that that board position is filled in, and then we can draw the figures that corresponds to that player. So we're iterating through the rows in the row variable, we're iterating through the columns in the col variable, and we're checking if it's the player 1, then that's filled in with player 1, and if that row position or that board position in the row and the column is filled in, then we're going to be drawing the circle, and we'll be drawing with the square size inside the square size and with the circle radius and the circle width. So we're drawing it in the middle of the square. That's why the square size divided by 2, and with the circle radius and circle width, we draw a circle that fills in the exact space of that square. If it's player 2, then we're going to be drawing a line, and we draw the other line. So we're drawing one line that takes up the green from left to right, and we draw the other line which takes from right to left, and that creates the cross with the different positions. Next up, we have a function that marks the square, so pretty much fills in the square with a specific player position. So it's setting up that port for that row and column that is passed on, and that we are assigning it to the player. So we're marking that square that has been used. We have one function that is telling us if that square is available or not. So it receives the row and the column, and if it says 0, then we return true, meaning 0 means it's not being filled by a player. So we return true, saying that that square is available. We also have one function to check if the board is full, and again iterating through the rows and the columns. And if it's 0, and then we return false, because if it's 0, like we saw before, that means that that's one particular square is available. If one particular square is available, then the board is not full, then we return false. If that does not happen, then that means that the board is full, and we return true. Then we have the function to check if a player has one. We pass in, of course, the player itself. First, we check for a vertical win. So if for each of the columns, we're checking the position, the first row and the second row and the third row. We're checking that particular column. And if it all matches the same player, then that means that the player has won in that vertical column. And then we call another helper function that we see later on, that we draw that vertical line that we saw at the beginning of the video. Same thing for the horizontal win, except in this case we are iterating through the rows, and we are checking for the first column, the second column, and the third column if it matches the player. If that is the case, then we draw again the horizontal line, in this case an horizontal line, indicating that that player has won in that particular row. Then we have the diagonal ascending, meaning if it's from the bottom left to the top right. So we're checking the position 2, 0 and the position 1, 1. So this is the center, and this will be the top one. So the row 0 and the column 2, which is be the top right, row 2, column 0, which is the bottom left. And if those diagonals with the one in the center, if that is true, then the player has one in that diagonal position. And the same thing for the other diagonal position. In this case, it's the top left, again the center, and bottom right, in terms of checking if everything has been filled in by the same player. And if that's the case, you draw then the diagonal, the winning line diagonal for the other position. So next, of course, we have the line that we were just seeing, the lines that we were just seeing before, the function that we were just seeing before, that draw the winning lines. So I have first to draw the vertical winning line. So we take the position X, that is from that square to which that column belongs to. The color is black, and of course we draw a line that goes through all the squares from that position and just fills them in with a stripe, let's say, with a line. Same thing for the horizontal. I draw the horizontal line, except in this case we use position Y, and that's from the row. With the color is again black, and we start our position, and we go through each of the columns or the rows, sorry, and so that we can draw the line. The diagonal, same thing, color black, and in this case we start from the bottom left until the top right with a specific line width. And this we start at the top left to bottom right with that specific line width also, and so we draw the two diagonal winning lines. So after that we have our main game loop, but before that we first say that we start the game by in player one's turn, and we're just keeping a variable to indicate if the game is over or not. So we're just doing our main game loop, just a while through. So as you saw, we draw the lines, meaning to create the squares, and then we draw the figures when the particular player has filled in that position. We are going through the game events or the Pygame events. If it's a quit event, meaning if we have closed the window, then we shut off Pygame with quit, and we also exit the application itself. If the event type is a mouse down and the game is not over, that means that we have clicked in a particular coordinate, and if that's the case, that means that the player is playing. So we retrieve the position with X and Y from the event position 0 and position 1. That indicates the X and the Y of that position. We transform that position by taking consideration the square size, so we can determine which row was clicked and which column was clicked. Then we check if that square is still available, meaning if it has not been filled in already with the player by using the helper function we saw before, by that row and that column. If that square is available, then we mark that square as being filled in by a particular player, so the row, column, that particular player. And then we check if that player has won by using the check-win helper function that we saw before. If that's the case, then the game is over. And if that is, we just then change the turns. So if it's player 1, it becomes player 2. And if it's player 1, this transforms it into player 2. This continues the iteration, and of course we update the display, so we draw the positions in the game itself when the player has played, and we just go through this loop, and every time that the player clicks, if we check the square, we mark the square, we check if that player has won, and we switch turn, and the game loop repeats itself. As we've seen before, let's again see the game in action. So I start with player 1. It switches to player 2. Player 2 is playing, now it's player 1. We try to play our best, try not to lose, and we do the different combinations. In this case, we're going to be winning the vertical. So as you can see, the check vertical, the draw line vertical, and that's how the game is built. Next up, we're going to see how we can build the same game, but we're going to be introducing one human player and playing against the AI as the second player. So next we're going to see how we implemented the AI version. So we have the Tic-Tac-Toe AI Python file. We're going to be using, in terms of the AI, we're going to be using the min-max algorithm, which determines which is the minimum and maximum possibilities of score for a particular player, for one player and for the opponent. So that determines what would be the best move for that player. So the AI player is going to be player 2, the human player is going to be player 1, as we saw, and the AI player plays always optimal, so it never loses, so it's quite tricky to play against this implementation, but let's see how it is implemented. So a lot of the code is similar, so I will not repeat here, but we have our imports, we're initializing the Pygame, we do our screen, our color definition, we do our board, initialize our screen, initialize our game board. We have the same draw lines function. We have the same draw figures function, which still draws player 1 and player 2. We have our mark square function. Then we have the first difference in terms of the implementation. Besides marking square, so besides a mark square function, we also need an unmarked square function. And why do we need this? We need this because when the min-max algorithm is determining which is the best move, it's actually playing all the possible moves ahead from a particular board position. So that means it's going to be marking the square. But of course, when the min-max algorithm finishes analyzing, we need to unmark that square. Otherwise, the whole game board would be filled in by the possible moves that the AI is trying. So we need to unmark all the squares that the AI has tried as a possible move. We need to unmark those squares. That's why we have an unmarked square, which receives a row and a column and just sets to whatever is that game board position, sets it to 0 again. We have the same visible square, checks if that board position is 0, then it returns true. We have the chain is board full function, that is the same. Then we have another difference in terms of the check-win function. It still receives the player, but as you see now, it has the drawing winning lines true. So by default, when this function is called, it's going to be drawing the winning lines. When this is being used in the min-max algorithm, as we're going to see later, similar to the mark square and unmarked square, when the check-win is being used by the min-max algorithm, in case if it determines that it's a win, and that's the best score that the min-max algorithm can draw, then we don't want it to draw the lines, because otherwise that will also be showing up in the game board itself as the player has won. So as we do unmark the squares, we also, in this case, do not draw the winning lines when it's the algorithm that is checking for a win. That's why we have this draw lines parameter there. By default, it's true, but when it's being called from the min-max algorithm, it's going to be passed as false, as we see later on. The same logic that we had before, checking the vertical win, the horizontal win, one diagonal win, the other diagonal win. and the same functions to draw the lines when they're actually called. We draw the vertical, the horizontal winning, and the two diagonals in case of the win. And now we come to the AI implementation. So the AI implementation is based on two functions. There's one that is the actual processing of the min-max algorithm, and there's one helper function that determines what is the best move of processing that algorithm. So first we check the min-max. It receives the board, that the current version of the board, the depth that we want to go through, and this when it's being called from the best move, it goes several depths, meaning it goes through several different moves, and which one is the player that we want to maximize the score for. And so first thing we're checking if it's a win for player 1, meaning for the human. In that case it's -1 for the AI. In case there's a win for player 2, that means it's possible best score for the AI, so you return 1. And if the board is full, that most likely means it's a draw because there was no win before. Then we return 0. That's a neutral possible move. Then we are checking if the algorithm is analyzing the maximizing player, meaning the AI, which is going to be passing there, or if it's doing for the human, which is the best move. So when it's for maximizing the player, meaning when it's for the AI, we want it to be the highest maximum score. So we are initializing the max value with a negative value, so that when there is a move and it's a positive move, which will probably most likely be 1, then this gets incremented and we can establish that the max is the maximum value. So iterating through the row and through the columns, we're checking if that square is available. If it is available, then we are marking that square as being used. And we are then calculating the score by calling again the min-max algorithm. We're passing the updated board position, and we're incrementing the depth, meaning it's the next move, and we are switching the players. So the algorithm was checking the maximizing player, which would be the AI. When the AI plays, which means marking the square, we call the algorithm with the human player, and we determine what is the score of the human player, so that we can compare and see if our move is going to be having the best possible score. Then we mark the square after establishing that score. And after getting that score, and we determine that it was the best move for the AI or not, and we determine by seeing if that score that was obtained, does it have a maximum, it is the maximum of the possible other moves that we analyze, then we set the max value to that one, and we return for that. So we're calling the min-max, alternating the players, and to check if a particular move, what kind of effects does it produce for the player that is playing at the moment, which is in this case the AI. We do the same thing for the reverse player. So we check the minimum. In this case, we set it to a positive value, so that when the minimum is minus, then we can observe that. We're iterating through the rows and columns. We're checking if that square is available. We're marking that as a move from player 1, meaning the human. And then of course we're checking the score and the next move for the AI. We're determining which is that possible score, which we want it to be the minimum score possible for the AI. In this case, then we'll mark the square, and we score if that move or that move score was the minimum that we can find. If that's true, then we return that value. Then we have the best move function, which again we want it to be the maximum score. So again, initializing the maximum value. We're initializing our move, possible move, initially as empty. In this case, as -1, because that's not a valid position. We iterate through the row and column. We are checking if that particular square is available. We mark the square as the AI playing, and then we initialize the processing by the min-max algorithm by passing the game board, by passing the initial depth, which is 0, which is the initial move, and then we exchange the player. And recursively, as we saw before, the min-max function gets called and establishes a score for that particular move. We unmark that square, and if that score is the maximum that we can do of all the possible moves, then we save that max score, and we establish, because it's the maximum score, we establish that that move is going to be the optimal move for the AI, and we return that move after we finish going through all the different columns and rows. So again, we're going through our main loop. We're starting again with the human player as the first player. We're having our game over available. We're iterating through our game loop. We draw the lines, we draw the figures. We check if the game is finished by the window is closed. We still check for a mouse event and when the game is not over. And if that is player 1, then we establish get the position X and Y. We do the same as before. We determine what is available, what is the click row and column. We check if that square is available, and if it is, we mark the human player as playing that square. We check if the human player has won, and then we exchange in the player, the current player, to become the AI. And when the AI is playing, so if the current player is player 2, and the game is not over, so if the human player has not won before, so the AI can play. We establish the best move that the AI can do from the best move function we saw before by using recursively the minimax algorithm, and that will be stored in the AI row in the call AI. We check if that square is actually available. Might not be available if the game has already ended, and that has won and has ended in a draw. Because keep in mind, the game over, actually, it's only filled in when there is a win. When it is a draw, we just run out of available squares. So that's why even with the AI, we're checking if that square is available. We mark that square by being played by the AI. We check if the AI has won. And again, if the AI has won, then the game is over. And we exchange the player to become then in this case, the human player. And we update the display to render all the lines and the squares and the figures for the different players. Let's also see the AI game in action. So I play with the circles. So this is me playing. That's the AI response. I'm going to try to win the AI. Let me put here. You see the AI defending. Now I need to defend from the AI. The AI determined that test was the best move. I establish here to counter that. And the AI played there, which was also the best move for the AI. So not to allow me to win. And I played there, and we ended in a draw. And if I start the game, you see from the different combinations that I might try, we see that it's very difficult to win against the AI, because the AI always plays optimal and always knows what is the best move from the AI point of view, so it will almost never lose the game. And that is it. That is all the code that is necessary to implement both the human 2 players tic-tac version in Pygame and also the human against AI version in Pygame. So like this video if you like this content, and follow me for more content regarding Python and Pygame and Django in AI also. And so subscribe to my channel for that to keep up to date with that content. And until next time, happy coding.